So hello everyone, welcome back to my YouTube channel, your KGPN bro. In today's video I am going to discuss about method to find out lone pair present on a particular atom when the bond formed by that atom and charge on that atom is given. So here it is the steps. So this is the step number 1. So first of all, identify the atom whose lone pair is to be calculated. तो जिस एटम का लोन पेयर निकालना होगा सबसे पहले उसी एटम को हमें आइडेंटिफाई करना होगा. फर्स्ट ऑफ ऑल आइडेंटिफाई द एटम हुज लोन पेयर इज टू बी कैलकुलेटेड. दिस इज द फर्स्ट स्टेप. देन स्टेप नंबर 2, फाइंड आउट ऑल द बॉन्ड्स फॉर्म्ड बाय दैट एटम. स्टेप नंबर 3, most of the bonds in chemistry are basically covalent bond, and a covalent bond consists of 2 electrons. So it is a covalent bond between atom A and atom B. So covalent bond consists of 2 electrons. So this electron comes from the atom A, that means it is the own electron of A atom. Similarly this electron comes from the atom B and it is the own electron of atom B. In step number 4, we have to show all the electrons which come from that atom, and we have to make a circle around that atom including all the own electron of that particular atom whose lone pair is to be counted. So you have to show the electrons which come from that particular atom, and we have to make a circle around that atom including its own electrons. That is the step number 5. And total number of electrons within that circle must be equal to valence electron of that particular atom minus magnitude of positive charge plus magnitude of negative charge present on that atom. If the atom has positive charge, then you have to subtract its magnitude, and if the atom contains a negative charge, then you have to add its magnitude. So here it is an example, and we want to find out the lone pair present on this oxygen atom, and this oxygen atom contains 1 positive charge. So we have to show all the bonds formed by the oxygen atom. These are the 3 bonds that are formed by this oxygen atom. So these are the electron present on these bonds. Out of these 2 electrons, this electron comes from oxygen and this comes from this carbon or something like. Similarly, out of these 2 electrons, this electron comes from oxygen, that means it is the own electron of oxygen. Similarly, between these 2 electrons, this is the own electron of oxygen. So we have to make a circle including all the own electron of oxygen. So these are the own electron of oxygen. So we make a circle around this oxygen atom including its own electron, and within that circle total number of electrons inside that circle must be valence electron minus, since it contains a positive charge, so you have to subtract it. That means valence electron is equal to 6 minus 1, that will be 5. But within this circle there are only 3 electrons are present, so rest of the 2 electrons will be acting as lone pair. So it contains only 1 lone pair. So here it is another example. That is the oxygen carrying a 1 negative charge. So first of all we will see the electrons present on this covalent bond. Out of these 2 electrons, this electron comes from oxygen, so this is the own electron of oxygen. So you have to make a circle including the own electron of oxygen. So we make a circle, and within that circle total number of electrons should be equal to valence electron. Since it carry a negative charge, so you have to add this, so it will be 6 plus 1, that will be 7. But it contains only 1 electron, so the rest of 6 electrons will be acting as your lone pair. So this oxygen contains 3 lone pair, 1, 2 and 3. So please note that negative charge always does not mean a lone pair. Negative charge does not mean always a lone pair. So here it is an example of BH4 minus. So it is the boron making 4 bonds with 4 hydrogen, And first we saw the one electrons of boron. By including these one electrons of boron, we make a circle, and so within that circle total number of electrons would be equal to valence electron of boron. Since it contains one negative charge, so you have to add plus 1, so it will be 3 plus 1, that will equal to 4. But within this circle already 4 electrons are present, so this boron atom does not contain any lone pair. So here it is another example. This is the double bond, oxygen, single bond, and containing a positive charge. So first of all, we have to make a circle around the oxygen atom, including all its one electron. So these are the one electron of oxygen atom. We made a circle around it, and within that circle, total number of electrons would be valence electron of oxygen. And since it contains a positive charge, so we have to subtract it. So it will be 6 minus 1, that will be 5. But within this circle, total number of electron is 1, 2, and 3. But rest of the 2 electron will act as lone pair, so it contains one lone pair. So here it is the summary. First of all, what you have to do, you have to identify the atom whose lone pair is to be calculated, then show its one electrons and make a circle including its one electron, and within that circle total number of electrons would be equal to number of electrons in outermost shell or valence shell minus magnitude of positive charge plus magnitude of negative charge. This is the summary. So thank you for watching this video.